Welcome all to today's ASRG-WORLD webinar. We have the 7th of October 2021 and we are streaming from Stuttgart in Germany. Thank you for being with us. My name is Sven Schran and I am coordinating with ASRG the European locations. The Automotive Security Research Group is now approximately 4 years old and we are a non-profit organization which provides a platform for the automotive security industry, as well as related academics or organizations to share knowledge, build powerful networks and valuable collaborations. The community is for you and it is based on volunteer support. If you want to know more details about ASRG, please check out our website at www.asrg.io. Maybe you have an idea for a nice project and look for partners to realize it. You would like to start your own location, you have an idea about a service ASRG could provide to the community, or you simply know a great organization which could partner with ASRG. We are open to hear each idea you have in mind and would like to discuss how ASRG can support it. Don't hesitate and get in touch with us. You quickly can send us an email with your thoughts to hello@asrg.io. So, this is now enough from my side. And I don't want to keep you tortured anymore, because I'm sure you are waiting very curiously for our main presentation today. Like every time, in case you have questions during the presentation, please write it into the chat window below the video. After the session, we will have some more minutes for questions and answers. And now it's my pleasure to welcome Dan Murdock, Chief Architect, Connected Transport at Irdeto. Today, he will present to us Secure Biometrics in Vehicles, Theory and Case Study. And now I would like to hand over to Dan. The virtual stage is yours.
Thank you, Sven, and thank you for having us today. Is everyone able to hear me? Is this going out on the stream okay?
Yeah, it's okay.
Yeah, perfect. Thank you. So yeah, with Sven, I apologize. I'm sorry to make you wait, but hopefully it was worth the wait. I'll do my best to be exciting. As Sven said, I'm Dan Murdock from Irdeto. I'll take a second to introduce myself. In a second, we're going to talk today about the theory and practical applications of biometrics in vehicle, and in particular, voice biometrics is the case study that we'll talk more about. So about me, just so you guys know who I am, you can see my best haircut and my best trimmed beard here. I'm Dan Murdock, and I've been with Irdeto for about 15 years. I'm the chief architect in the Connected Transport Group. At Irdeto, in the Connected Transport Group, we're focused on not only on-road and passenger vehicles, but also on-road freight and trucking, off-road equipment like construction equipment, movable and immobile construction equipment, as well as rail applications. And so Irdeto has a fairly broad portfolio in the transport space. Today, I just to round it out, I come from prior to my role at Irdeto, I've worked for a number of different automotive OEMs and tier ones in a number of different areas, and have found my passion in cybersecurity in particular. So today, what I'd like to do is talk through Biometrics 101, in particular, as I said, related to voice. We'll talk about biometrics in the vehicle themselves and some of the details around voice. And then we'll talk about a case study we've done with a partner where we've done we've used voice for second factor authentication for in-vehicle payment, and how we've done that, the results we got, and some of the technology that we discovered and evolved along the way. After a brief summary, we'll open it up for Q&A, and my contact information will be available at the end of the presentation, so please feel free to reach out, as many of you have on LinkedIn or by email. We're always excited to talk about our technology and its application. So, Biometrics 101. There are lots of different modalities in biometrics, lots of different types of biometrics that can be collected. In terms of physiological biometrics, the most common to talk to are fingerprint, Face ID, palm print, or an iris scan. And in terms of behavioral, there are a number as well, including a gait analysis, as the pattern of your walking, a voice analysis, both of what you say and the identity of the speaker, and keystroke analysis on the keyboard, either typing on a physical keyboard or typing in a mobile phone. And then, of course, you can very easily extrapolate these to many other either combined or related modalities in either of these categories. So the biometrics process is relatively straightforward, regardless of the modality we're talking about, whether it's behavioral or physiological. It always starts with an enrollment process, which brings feature extraction. The first step is always to pull out the features from the biometric, store them, and indeed protect them. One of the key things Irdeto brings is not only the technology to perform this, but to perform it securely. And so, as a cybersecurity company, we're always looking at how are we doing these cutting edge things in a secure way. So after protecting them and storing them, you then move into the process of testing. And so you have a live capture event where you're attempting to authenticate, again, with a feature extraction from the live capture and a comparison, again, which should be secure in order to ensure that that process can't be easily tampered with. So in the end, ultimately, the biometrics process results in acceptance or rejection of the authentication request. So the KPIs of biometrics, it's really important that we all understand these and set a baseline, because it's not easy to understand unless you spend a lot of time thinking about it. So this is our amalgamation of the definitions based on both FIDO and NIST and ISO, excuse me, and making sure we're properly communicating in the same way with everyone. So in terms of what a genuine authentication challenge is doing, the KPIs really are around acceptance and rejection. So the true acceptance rate and the true rejection rate are really, has the algorithm performed correctly, or the false acceptance and false rejection rate has the algorithm made a mistake. And so the true acceptance rate and false acceptance rate would equal 1, because you have 95% correctly accepted and 5% falsely accepted, for example. And then the true rejection and false rejection rate would also add to 1, implying 98% correctly rejected and 2% incorrectly rejected, for example. What's important is that that's of genuine and non-malicious attempts or spoof attacks. The imposter attack presentation acceptance rate is a separate measurement, and we'll talk about that a little bit in a minute. And that is really what percent of spoof or malicious attacks or attempts to authenticate were accepted by the system. So if we look at this data, and I won't go through it in detail, but this is reference data from the NIST challenge that's run every year in a VoIP and regular telephony, traditional telephony application, validating phone number matching, same versus different. And so you can look at because these are cost curves. You can see the X's indicating the balance of the false rejection rate and false acceptance rate. FIDO has specific metrics that there are guidelines for reaching in terms of an acceptable system of 5% false rejection rate and 0.01% false acceptance rate. Those are the FIDO standards, and you can see that this represents about the state of the art in terms of the detection. If in the center graph, you can see that they're about achieving that. So now that's kind of what the industry of biometrics and voice looks like. Let's talk a little bit about biometrics in vehicles. So what can you do with biometrics in vehicles is really the first question. So in terms of advanced traditional security, an additional factor for keyless entry or for passive entry and passive start can be used. So telling the vehicle you're ready to start it and authenticating who you are. Authorizing a new driver or notification of unauthorized entry are good examples, and two-factor authentication. In the context of ADAS or driver assistance, driver aspect monitoring, including stress, fatigue, or distraction, is a really important part of what you can do with biometrics, and is really, has the potential to become mandated. As well as therapeutic lighting to help you perhaps relax in traffic or wake up if you're a little tired. And finally, surprising to me, there are actually a number of health and wellness applications of biometrics in vehicles as well, around heart rate monitoring and breathing pattern monitoring, as well as even things like massage and muscle therapy. So there's lots of different areas in which biometrics are being applied in vehicles today. And so some specific examples, Hyundai is already using face recognition to register and personalize the driving experience in the vehicle. So mirror adjustment, seat position, radio preferences, things like that. In terms of ADAS, Visteon and others have head and eye tracking, blink analysis, blink duration, and so in terms of fatigue analysis, it's an important part of ADAS, both with automated and non-automated drive. And then finally, as an example, Ford has seat sensors in the back that are actually able to detect and warn about impending heart attacks. They can presumably be used to detect and identify other conditions as well, but this is sort of a strong and dramatic example of it. So in terms of talking about these different modalities, they all have advantages and disadvantages. I'm not going to go through this chart in detail. This chart is really here just to show you that you have to take into account many of these things, cost certainly being one of them, user acceptance and ability to use them, and willingness to use them, the ease of use, the accuracy, and finally some of the really important challenges that you have to consider when implementing one of these things. If you look at fingerprint, for example, cold or dirt or dryness, or as you age, all of those things can impact fingerprint analysis. In terms of voice specifically, background noise or vocal changes due to illness or blocking your face can impact voice. The others all have their considerations as well. This chart is really just a level set to kind of highlight that if you look at where we were a few years ago and where we sit today, today approximately 6 million cars or 6 million vehicles, passenger vehicles, are on the road with some kind of biometrics and integrated. But if you look at 2024, there's a growth of 400% between 21 and 24, getting us to nearly 25 million vehicles. It's an enormous growth area, and it's an important area to consider. However, the most important commercial question to ask is, it's important, will customers pay for it? So this here we kind of demonstrate and show you a little bit of, where does customer concern lie, and by geography, about their car being a threat or someone attacking their car and risking their safety, versus what they're willing to pay. And so this chart shows that today the majority of consumers and vehicle operators would not pay more than 400 euros for the advanced technology options. And so that's simply a level set in terms of where the market's at for this technology compared to the perception and concern. It doesn't imply at all that they would never pay that, nor that it might change. So now we've talked about biometrics in general. We've talked about biometrics and its application to the automotive space. Let's talk about voice biometrics in particular. So some of the steps that are involved in voice. You always have to deal with enrollment. That's an important first step in any biometric, including voice. So creating and identifying a voice print. One of the key applications is identification, identifying one speaker amongst a set of speakers. Diarization, which is identifying all of the speakers within a recording and identifying and serializing them. Verifying a speaker against its identity. And then finally, removing an identity from a recording. So when you talk about identity in voice, you have to talk about the speech itself and what speech carries with it. So when you look at speech, obviously we all know the human ear hears up to 15 to 20,000 kilohertz, 15 to 20 kilohertz, excuse me, and down to 20 to 40 to, depending on your age, your hearing ability. But in a voice pattern, what you've said is typically carried in the lower range, below and around 1 kilohertz. So this is really, that area is what you've said. But who's been saying it, and the identity of the speaker is traditionally carried in the higher ranges of frequency. And so that's an important thing that we're going to touch on in just a second, as part of our case study. So in terms of using that data to, like I said, in terms of using that data to then create identity, FIDO requirements are less than 1 in 10,000 false acceptance and less than 5% or 5 in 100 false rejection. And then finally, less than 7% imposter spoofing acceptance. So these are baselines that FIDO has identified to say a biometric system must be this good to be deployable. So now let's talk about our case study. And what we were trying to accomplish in the case study was using voice as a FIDO compliant second factor authentication for in-vehicle payments during natural discussions with the digital assistant. So I want to highlight that during natural discussions is an important part of some of the learnings and things we demonstrated. So in terms of what we did, we brought Irdeto's Trusted Biometrics SDK, which is then connected with the sort of a connectivity independent way to secure biometrics. So it's microphone, it's reading and network connectivity independent, although there are some input hardware dependencies that we're going to talk about in a second. Irdeto offers today voice as part of our biometrics. Gate biometrics are in development in our research team, and we have research ongoing in face biometrics, not only around identification, but also around creating better identifications with interference. And in this case, in face, we're talking about wearing a hat or glasses, wearing a mask, fairly relevant today, and things like that. So we have a number of those other researchers in place building on the voice biometrics we have today. In terms of features, our biometrics platform has an enrollment step and a speaker identification and speaker verification step capabilities, speaker de-identification, speech enhancement, noise reduction, identity enhancement, and then finally speaker diarization, which is in development today. We don't need to go through it's a library you can include in an ECU in a vehicle. We don't really need to go through the details of that. So the use case. Now, big asterisk here, Volvo was not the customer. It's just they're just a nice OEM to use. So you're welcome for the free publicity, Volvo, but it was not Volvo. So I don't want you to draw any conclusions. So hi, Volvo, please pay for the parking. Speaker identification happens in the background to determine who's paying and how to address the user. Of course, Hans, that will be 13 euros. Okay. So that I know it's really you, could you please repeat the following? I love how safe my Volvo is. Speaker verification then steps in and uses here a random challenge to mitigate replay attacks and provide a second factor of authentication, which is an important step, not only in ensuring that it is the right speaker, but that it's not replayed. It doesn't take a lot to defeat replay attacks, to defeat practical replay attacks, I should say. So I reply, I love how safe my Volvo is, which the vehicle replies, excellent, thank you. The parking was paid using your MasterCard. So it again relates the data of that you've paid, how you've paid, and it gives you a very much a natural language interaction. But it's not easy. It's really important that in terms of training, as an example, because we're generally talking about a global market for technology like this, the training needs to be representative of the target population and the target languages that would be spoken, because they carry with them some differences. The training needs to be done in the real environment that the technology is intended to be used in. So training in a lab or in an anechoic chamber isn't actually very helpful, because it doesn't let you train the model to the real world, and your expectation on behavior will be very different. So will it work while driving on the highway, or when it's raining, or in a car wash, are good examples. And then finally, how does the hardware that you're collecting the biometric from support the biometrics? So for example, if you look at microphones are built to hear what you said. They're not really built to hear who said what was said. And so we'll talk a little bit about what that means in a second. So if you look at here, at this chart, here we're talking about looking at using a production microphone in a customer environment, and with varying durations of authentication and enrollment audio. So along the bottom, you can see the authentication, or the enrollment audio, excuse me, and then the authentication audio used to challenge that. So if you look at the best result we achieved was with 6 seconds of authentication audio against a 50-second enrollment. So not great, but not terrible. We can certainly always do better and continue to improve that, but we have achieved here FIDO compliance. So how did we achieve that? One of the key challenges here was the quality of the audio from the microphone. So at the lower frequencies, we were seeing noise and a little bit quieter. The higher frequencies were a bit louder, but there was a lot of the mid frequencies were quiet, and so where the identity was carried tended to be quiet. We did some work to enhance the audio. I won't go into that in a ton of detail, but we can certainly talk about it in individual interactions if there's interest. We did some work to enhance the audio to make it more possible to extract voice identity, and had a fair bit of success in doing that. And so we were able to dramatically improve the results we could get from the production microphones, which is a really important step in actually being able to broadly apply the technology. Another interesting learning from the case study was actually some sentences carry more identity than others. So depending on the number of syllables and the phonemes used in the sentence, you can get more identity information, more identifying information out of different sentences. So if you were to compare, say, where's the nearest charging station, which takes 3 seconds to say, or pay this parking fee with my credit card, which takes the same amount of time, you're getting almost 20% more identity information out of that second sentence. So choosing how you phrase your challenges and responses can dramatically impact your results as well, not only the hardware and the capture. So finally, the conclusions we can draw from our case study, it's really, really important to collect training data from the actual environments and from a diverse population, both from a language, ethnicity, and a diverse sex and other areas of variety, age, of the expected population of use. The model, not only do you need to collect the data, but the model needs to be trained with data in that environment. You need to meet FIDO requirements because you need to meet regulatory requirements in order to be able to deploy this technology. You need to make sure that the hardware you have can, together with software, achieve the results you need. So you need to make sure you test that, because deploying this after testing it with one microphone and deploying it with another will give you dramatically different results. And finally, as I just mentioned, some sentences carry more identity than others. So carefully choosing the dialogue to achieve the identifying information you need is very important. So just in summary, I guess, voice biometric security and performance is a combination of the model and the data, and the training data itself, as well as the hardware and the dialogue design, is really how I would summarize the results from our case study. So thank you. I really appreciate, hopefully, your attention. Hopefully you haven't all nodded off. This slide, I'm going to just highlight here. I'm going to leave this up on the screen perhaps while we maybe take some questions, Sven. This is really a summary of what I've talked about, and just might give you some areas to remind you of some of the earlier aspects of the conversation and areas you may want to ask questions about. So thank you for your attention.
Okay, so from my side, thank you for providing us this overview and bring also this biometrics topic to our community. Let's start with one question. Can you provide us an outlook which use cases you see in future for biometrics in vehicles? Additional to that one, you told us about today, for sure.
Yeah, so I think payment is an interesting one because it's simple and it doesn't involve one of the reasons it's easy to focus on is because it actually doesn't involve the operation of the vehicle. So there's no safety or security considerations around the vehicle itself. They're only a service through the vehicle. But to me, I think that the key biometrics use cases are those that make the usage of the vehicle more seamless to the user. I think the users of technology, as the world is showing us, are increasingly looking for things to be simple and easy and touch-free and complication-free. Sort of the Appleification of things, right? Things just work. So some of the things I think are great are things like Face ID, to give you that second factor of authentication without having to take your phone out or take your key out or do things like that. For preferences, so setting the radio station, I think just setting the radio station and moving the seat and the mirrors is a big step if it does that automatically by your voice, like it does with your key. Because what's really important to remember is that I think as you're going to move from physical keys to digital keys, for example, and things will change and can grow with that as well. So you could carry your profile with you in your phone. Suddenly, maybe that same thing can happen in other cars. So things like that are really nice. And then I think safety is really the other one. There's already a lot of aspect detection, driver monitoring features. Those are really important, and I think they're only going to grow. I think they're probably going to become legislated over time in different geographies. And so I'm excited about those. But what's really exciting is that I think there's a lot you could do with it. A fingerprint scan, a fingerprint reader right on the wheel, for example. There's lots of interesting stuff you can do that I think I'm looking forward to people experimenting with.
Only an idea of myself. Did you also just heard about a use case where maybe for a private car, the driver will be identified via voice or iris scan or something like that, and only if the driver is known by the car, let's say like this, the car is starting and can be used. Such.
Absolutely.
Okay.
Yeah, absolutely. The only, like I said, the challenge there is when you get into the actual use of the vehicle versus the sort of enjoyment of the vehicle or safety, you start to get into, there's a lot more considerations around, well, what happens when it doesn't work, or if I have a Band-Aid on my face, or, you know, all of those kinds of things that there's a lot of corner cases to address, which will get addressed just like they are with many other cases. But that's why it's nice for some of these simple use cases to get started, because they let the technology develop such that you can then address those more complex cases.
Yeah. So the use case I mentioned might be also interesting for truck business, for example, if the driver should be known, right? It's an employee for one company, and if they can use these technologies to make the truck running, then this might help also to prevent stealing of trucks or something like that.
Absolutely, and well, I absolutely agree with you. And as I mentioned, I mean, we have technology in the trucking space around digital key, in fact, and on our roadmap is bringing this technology into that solution as well.
Mm-hmm. And from security perspective, what do you think is there the biggest challenges? So if we speak for the use cases before, if we make the decision about the detection of the driver via voice and so on, I think it must be also secured that it not may be hacked by a malicious identification attack or something like this, right?
Yeah. So there's two angles to this. Well, there's actually three, I think, angles to the security. The first is, of course, consumer privacy and right to be forgotten. When you look at, for example, the way a lot of these technologies work, when you train a new voice into a model, you're layering it into an existing model. So the right to forget that voice from the model is extremely important, and you can't overlook the privacy considerations. The next is the IAPR, or the fraudulent use detection, which has a number of which is partly training, partly security measures to identify those threats and those activities, which is important. And we have research ongoing in sort of the protection of models and the tampering of models like that. And then the third is the more traditional data protection concerns around, you know, how do you ensure that the model data and the identification data that's sitting on in the vehicle is actually secured from attackers, so it can't be lifted and then used for something else, or augmented maliciously and then re-added. And so from that perspective, you know, as a cybersecurity company, we have a lot of technology in Irdeto geared towards making sure data is not tampered with, making sure data remains authentic, making sure it can't be used on devices other than it's intended to be used on. And so we've applied a lot of those technologies to this to ensure that we're doing secure voice biometrics.
Thanks for responding these questions. We received another question related to your example of payments. So the question is, will the payments using any kind of biometrics need to be integrated to some kind of app, such as Apple or Google Pay?
They can be. In this case, the payment is driven through the vehicle itself, so that it's driven through the vehicle and into the, and because it's actually just a case study, I wasn't really tied into an actual payment. The payments have to be driven through something. It could be Apple or Google Pay. It could be Apple Wallet or Google Pay, but it could also be something through the vehicle and the OEM itself in this context. But it would have to be through something. It could be a third-party app, not the native mobile app, but something will need to do that. And I suspect, I wonder if over time, some of these two-factor authentications like this may be integrated directly into those kinds of apps, those services themselves. So if you integrate it in with Google Pay or Apple Wallet as a potential, as one of many ways to authenticate yourself, as a secondary way when you're in the car, for example, there may be advantage there as well.
Yep. Okay. So that for now we don't receive any more questions from the audience. I think yeah, your presentation was quite. Now, if I say that, there comes in something else. So let me pick
Sure.
it up again. So I read it. Will there be an e-wallet in picture where a user will be registered, then integrated with third parties, and authentication is happening through biometrics? What do you see as future of this technology?
That's a good question. It could go in lots of different ways. It depends on, like, we're looking at it really from the vehicle perspective, and so from the vehicle perspective, the OEM's goal is typically to be involved in that process and to make it seamless for to make those interactions seamless from the driver's perspective. So paying for parking, paying at a drive-through, picking up a cup of coffee, paying for fuel, if they can make those things seamless and then also pick up, if they're delivering it as a service, maybe pick up something, a percentage of the transaction along the way, I think the OEMs rightly recognize there's a lot of value in that for everybody. I'm not sure whether it would go in the direction of fragmented or whether it would go in the direction of harmonized, because it could harmonize in an e-wallet with plug-in identification technologies based on the platform it's on, but I'm not really sure. From a finance perspective, I'm not actually focused in that area, so I can't really give you an intelligent answer on that. But I could see it going either way.
Okay, so that now was the final question. I would provide you the stage again to say some final words to the audience for today.
Thanks, Fed. All I would say to wrap up is thank you again for your attention. I hope you enjoyed the presentation. And if you have further questions or would like to learn more about our technology or Irdeto and our other products in general, feel free to reach out to me. I'm at dan.murdock@irdeto.com or on LinkedIn, Dan Murdock. You can also check us out at irdeto.com, where you'll find a lot of information on our video products and our connected transport products and our other things. And yeah, I hope to see you again in another webinar. This was a lot of fun. Maybe the final slide I'll flash up just so it can be seen is that here are some of the references that you would have seen in the slide. So if you're watching this video again at home and want to read some of these, feel free to take a look. So thanks, Sven.
Okay, then from my side as well, again to you, Dan, thanks to bring this topic into our community. Thanks for showing us this case study from your point, and also to be open to discuss and answer the questions we received. Very well done. And also to our audience, I can agree with Dan. I hope you enjoyed this webinar today as well. It's nice to have you with us. I wish you a good morning, good afternoon, good evening, wherever you are in the world, and hopefully we see us again in one of our upcoming webinars. So thanks for participation, and bye-bye for today.